Hello YouTube, so today we're going to be looking at the circuit right here. All these brown boards right here are part of the circuit, and the circuit is a 7-segment decoder. Basically how I made it is, you look at the 7 segments on a 7-segment display. I labeled each one of them A, B, C, D, E, F, G, and then I identified which of the segments is on for each number. So one is going to be D, and also A. So you're going to D and A, and that's 1. And it goes for all of these as well. And once you identify which of these segments is on for each number, you can then do K-maps, which is all of this, to reduce the functions to a Boolean equation which you can implement using transistors. And the transistors which I use are 2N2222 bipolar junction transistors, which are these ones right here. Also, it's resistor transistor logic. So you can see I have 10K resistors and 4.7K resistors as well. The 10K resistors go on the base of the transistor, and the 4.7K go on the emitter, which goes to ground, or it could also go on the collector if you're doing an inverted gate. You could see, oh, there's a lot of circuits right here. Well, they're actually not very complex. It took a long time to make this, but I'm really only using 3 types of gates. There's OR gates. You can see this is a 4-input OR gate, which is basically just 4 transistors in parallel. If you know how an OR gate works, is if any of the inputs is high, then the output is high, which is a screen wire. So if they're all in parallel, then there's a path for current to flow if any one of these 4 inputs is high. I also have Nand Gates, which are these ones right here, which is, it's only low if both of the inputs are high. And I just have a bunch of 2-input Nand Gates. I also have inverters, which are just these single transistors. It's hard to see because of the wires, but these are single transistors, which they work by inverting the input. So also, if I have an AND gate, which I have to implement, it's a NAND gate and an inverter. That just makes it simpler for how it works. You might do it differently if you were doing different transistors. So in the last video, I made the same kind of circuit using an Arduino. It was much simpler than this. This is by no means an efficient design. It uses 1, 2, 3, 4, 5, 6, 7, 8, 9 boards, if I count properly. But if you were going to implement this in practice, you would just use a simple IC, which works as a 7-segment decoder. So these are your inputs. You could have 1, 2, 4, and 8, and you could see that it's giving you the proper output. So let's just count up from 1, 2, 3, 4, 5, 6, 7. Okay, 7 requires 3, 7, 8, 9. So that's as far as it counts. This is not a hexadecimal display, so if I do 9, 10, it's not going to be an A, it's going to be whatever this is. Which is just complete garbage because I use them as don't cares. So the X's are don't cares, so they could be whatever, just to simplify the design. If I wanted to display hexadecimal, it would be a much more complicated circuit than it is already, and this is already kind of a ludicrous project to begin with, to go through all this effort to make all these circuits that would only do a basically simple function, which you could implement using much faster any other way possible. So let's continue. 9, 10, 10, okay, that. 11, which looks like a different kind of 9. 12, which is 9 again, even though it's 12. 13, which is 5 for some reason. 14, which is 6, okay. Yeah, you could see the don't cares, they don't care about the last one. And then 15 is 9. So it's going to be 10, which is Q, 11, 12, 13, 14. Okay, I'm not going to jam these buttons anymore. 14, 15. Okay. So it only works for the 0 through 9, which is what you would want for decimal, for binary coded decimal inputs. And also in this last board, you can see that I kind of ran out of solder. So I just kind of twisted the wires together. When I get more solder, I can fix it. Though I went through an entire roll of solder to make this. And it decided to turn off. Okay. Yeah, I think something's shorting out on that one. So yeah, this is a 7-segment decoder using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boards. So I challenge you to make a more inefficient 7-segment decoder. Maybe you could make one out of relays or vacuum tubes or something. But other than that, this is about as crazy as you're gonna get. So I'll see you in the next video, probably where we will be looking at some other circuits which might be more worthwhile to actually build. I hope this was fun for you just seeing this, and see you in the next video.